Hello, this is the second day of the Advent of Code 2022. In this video, I'm going to read the statement, which I haven't read before. I will solve the problem and then refactor the code until it is as clean as possible. I will solve the problem in Python and I will finally write down the lessons that we have learned or the Python features and tricks that we have used to solve this problem. So if you wish, let's read the statement now. Okay, as always, we have some kind of explanation in the beginning. We could go down and see directly the input. So we see this is pairs of letters. Let's see the whole input. Okay, again, it's pairs of letters. So we have a clear idea. Let's copy it right now. So we already have it. So this is the input for the second problem. We can also copy the example. Might come handy. So let's do that too. We write it to 2.example. Now let's read what the problem is about. So for example, suppose you were given the following strategy guide. So this is a strategy for encrypting something. Let's see what this means. The first round, your opponent. Well, let's read the statement instead of the example. There's an encrypted strategy guide that they say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, C for scissors. Okay. The second column, suddenly the elf is called away to help with someone's death. The second column, your reason, must be what you should play in response. X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected. 1 for rock, 2 for paper, 3 for scissors, plus the score of the outcome of the round. 0 if you lost, 3 if it was a draw, 6 if you won. Since you can be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you were given the following strategy guide, okay? This strategy guide predicts and recommends the following. In the first round, your opponent will choose rock, and you should choose paper. This ends in a win for you with a score of 8. So this is the classic game where paper beats rock. With a score of 8. 2 because you choose paper, 6 because you won. In the second round, your opponent will choose paper, B. And you should choose rock, X. This ends in a loss for you with a score of 1, 1 plus 0. The third round is a draw with both players choosing scissors, giving you a score of 3 plus 3 equals 6. In this example, if you were to follow the strategy guide, you would get a total score of 15. What would your total score be if everything goes exactly according to the strategy guide? Okay, so the strategy guide means that ABC is rock, paper, and scissors, and XYZ is X is rock, Y is paper, Z is scissors. So what we need to do, if I understood correctly, is we need to read all of the games, and then we need to sum what is the total score. Okay, so we'll have to open. Let's start with the example, right? So we open the example, we read, we split lines. So, and we could say games equals, so line dot split for line in. We could ignore all this for now because we are reading all of the output. So let's print the games and see that we are on track. We run this script, we get this list of games. So the total score can start from 0. So we need to, for G in games, we need to iterate through all the games and we need to sum the score, right? So we can say total score. We could say we could create a function for this, right? So we could be score. Instead of game, we could say A and B. So score of A and B for each of these two elements. Then we print the total score. So this would be part one. Of course, we need to define this function score. So for A and B, we will refactor this code later because A, B maybe are not the best names, right? So we could map what each character means. So we could say, I don't know, let's call it map for now. It's a pretty bad name. Let's go with that. So basically A is rock. B is, let's go to the statement. B is paper. C is scissors. And we copy this back. And I guess this is X, Y, Z. We will also need another map to get the points of each of these. So these points, so what is the points for rock? It is 3 points, I think. No, 1 for rock, 2 for paper, 3 for scissors. So 1, 2, 3. Should be formatted better. Okay. So we have these points. So the score would be, and we would need to find if wins, right? So who wins in or the outcome, right? So we could say there is a tie always if A equals B, right? So we could say A equals map A. So we need to convert each character to the whatever rock, papers, and scissors, right? So if A equals B, then the outcome is the score is 3, right? So let's have this return variable. So red equals 3. If you lose, let's check again. If you lose, you get 0 points. If you draw, it's 3. And if you win, it's 6. So I think B is the one that is your draw. So it is 6 and else it's 0. So it is 3 and 6. And then finally return red plus the points of B. So here what we do is get the points of the outcome of the game. And here we return the outcome of the game plus the points of whatever you played. Let's see if this works. 15. Yeah, that is right. That is what the example means. So let's try to run it with the input. Of course, as I said, we can improve this code a lot. So basically, this is what I got. And the answer is not right. It is too high. Okay, so we need to do something. This is not correct. Let's check again if X, Y, Z are what we said, rock, paper, scissors. X is rock, Y is paper, Z is scissors. Okay, that is correct. The total score, it is the shape you selected, 1 for rock, 2 for paper, 3 for scissors, and the outcome of the round is 0 if you lost, 3 if it was a draw, 6 if you won. Oh, I didn't. This is completely wrong. So this is not what I mean. This is a tie, but this is not what we need to do. This is completely wrong. So if the values are different, then there are different cases, right? So it is if, let's say, A equals scissors and B equals rock. So that's what we so or if A equals rock and B equals paper, or if A equals paper and B equals scissors, right? These are the rules for winning. So that's a completely different thing. Again, we could run the example, but let's try to submit the solution again. And now we got the gold star. Okay. It is pretty obvious that we can improve this very much, right? So we could say we could have some constants like RPS, for example, for rocks, paper, and scissors. Maybe it would help make this more. I think if I remove this, it could be formatted this way. Okay. And again, this paper, scissors. So here we could do this too. So just getting more concise helps. We could maybe later even use some kind of name tuple or something like that. So this helps and we still get the same solution. Okay, like we did yesterday, we're going to add an assert here. Total score equals this, which will help later know that we're on track when refactoring the code. Okay, so we will improve this later for sure. But for now, let's continue with part 2. Okay, DL finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. Okay, that's a different thing. The total score is still calculated in the same way, but now you need to figure out what shape you choose. Okay, so this is pretty easy. X means you need to win. Sorry, let me read that again. X means you need to lose, Y a draw, and Z you need to win. Okay, so that's pretty simple. If we could copy this. This is pretty simple. What we need to do, because there's always if you need to win, there's a single shape that can make you win, and if you need to lose, there's a single one, and if you need to draw, there's a single one that you need to choose. So that is pretty easy. What we can do is we could even use the same. So instead of using this function x score AB with XYZ, what we're going to do is we're going to say shape R. So we're first going to modify the first part, right? So in the first part, we said that X meant rock. So we can do we can do the following: dict zip, so x, y, even x, y, z. Well, we can do this later, but x, y, z matches rock, paper, scissors. Shapes. Let's see if this works right now. Okay, there's something wrong here. Parentheses in the dict. Sorry, this is it. I think we will refactor this later. Let's refactor this later, but later you will see the idea that I had on how to solve this. Okay, so the point is that what we need to do is to substitute b for whatever it is. So if b equals x, it means we need to lose. We need to lose. Else if it is y, we need to draw. Else if z, we need to win. So in this case, it is very easy because if we need to draw, it means b equals a. So we just need to make it the same. If we need to lose, we could have a dictionary loses, which says that rock loses against paper, paper loses against scissors, and scissors loses against rock. And this one will be the reverse thing. So there's probably a better way to do this, to reverse this, but basically it's wins paper, wins against rock. Sorry. Scissors wins against paper, and rock wins against scissors. So here what we need to do is b equals wins b, loses. So what we're doing now is we are substituting, replacing the b, which would whatever shape wins against b, and here replacing b with whatever shape wins against b. Okay, there is an error. Oh, because what we need to do is we need to map this thing. So we need to map this. Let's do the following. Well, what we did here, right? AB, we are going to replace this and do this here. AB equals this. We're going to do this, the same thing here too. So we don't do that twice, and now we can remove this. Okay, so now something is wrong because we're getting exactly the same solution. So let's print wins total score A, B. So if B equals X, well, no. We don't have to map the X here. We are doing this wrong. We just need to map the A, and then here we need to map the B. Okay, now we got a different score. We could submit it directly. Yeah, let's do it. Okay, it is too low. So we got it wrong again. We were too quick to submit it. So it is too low. Let's see if we can find what we're doing wrong. Let's try with the example first, which we didn't do this time. well, of course, this one, the assertion is wrong. Let's comment it out. Okay, 11. That's good because the actual score is 12, so we got it wrong. So let's print here what we're doing. Print AB. Let's print what we're doing. So we are having 1 against 1, 2 against 2, 3 against 2, which is already wrong. Because these are two ties. And in the example, the second is the first X is not a tie. So let's see what we're doing wrong. In the first round, your opponent will choose a rock, A, and you need the round to end in a draw, so you also choose a rock. Okay, that is right. In the second round, your opponent will choose a paper, B, that is right. And you choose a rock, so you lose. So we are not choosing a rock. So what is going on here? B equals, in the example, equals X. So if B equals X, B does loses map B. So let's see what's going on here. Print B map B. X1. And loses of map B. What does it mean? Oh, sorry. We don't need to lose against B. We need to lose against A. That is what is wrong here. That is what is wrong here. We need to lose against A. If I got it correctly. So let's also print the score, right? Score AB. So 114, that is correct. Then here it says 239. This is not correct. So in the second round, your opponent will choose paper and you will choose rock, so you lose. So here, your opponent chooses paper, A, so we need to, maybe I think we got it in the opposite direction. So we need to lose against, so let's say, lose against, so if you need to lose against rock, you need to choose a paper. So it is the opposite, right? So let's, for now, replace these two directly. Now we get the 12. I think we got it right this time. Let's run the input. And then we will do some very, very heavy refactoring for this problem. It said we had to load the past. Okay, now we got the gold star. Okay, so finally we got this solution. I think this problem is nice. I like it. But I didn't solve it in a very good way. The code is pretty big. Sorry. And I think we can simplify it a lot. So again, we added two assertions. Everything is working. And now let's try to refactor this code. Okay, first of all, what do we have here? We have all of these games. Red, this is fine. Let's add a comment. So read input. Okay, that is good. Then we have to choose to calculate this score. So we have this wins right? The wins that we save here, we could make it global, and the same with the losses. Can make it global. So here, the score would be 0 if there is a, so it's 3 if it's a draw and 6 if there is a win. So here it would be if wins A equals B. So if wins A equals B, so the one who wins the rook, which is the paper, is B, then we return this. Sorry. Is that right? Yeah. Okay, so we simplify this a little bit, and then we have this, the return is this plus the points of B. So we could probably refactor this again. So game score, so this is the score of the game, plus points of B. We can extract this, right? Game score plus points of B. Is that right? No. Oh, because we need to remove this sum here. Let's see. Okay, now we got it right. So what we could do here, again, to simplify this function, it is return 3, return 6, return 0. Because we have returns, it's not necessary to have these ifs, and we could, well, we could do this, but the automatic formatter is going to put it in a new line. So basically, the game score is defined as this. If the values are equal, if there's a draw, it's 3. If A wins B, there's a 6. Otherwise, it's a 0. Okay, so now how do we compute the part 1? How can we simplify this? So we are reading all of these games with A, B, X. So we could say, when we do this mapping, ABX, ABX, so I think mapping B should be done separately. So B could be whatever we have here. I don't know if that will work. Hopefully it will work. I'm not sure. Yeah, it works. So here we are translating XYZ with this value, right? And here the B, what we're doing is we're choosing it according to this. If it's X, the one that loses, and if it's Y, the one that wins. So how can we improve this even more? We're also using the points for each. So we have the game score. Well, it's not the game, it's a round, right? I think it's set. The score of its round. So I don't like that we're doing this mapping here. A map. I mean, I don't like the word map, and I don't like that we're doing this this translation here. We could do it when we read it. For A, B in games, and we could do map A, B, for A, B in line split. Does this work? Well, it will not work if we don't do this in the right order. Didn't compile, but I don't think either that it is the best idea to do this. Okay, so what don't I like of this code? First of all, it seems we have redundant things, so we have different ways of naming things like RPS, excuse me, with map. I don't like this map, so, and the losers and wins. So here game score or round score, okay, this is fine. A, B, plus points, def round score AB could be game return game score AB plus points of B. So instead of having game here, we can have round, and we remove this, and the same here. So we have simplified a little bit with the sum. And now it would be interesting to have this mapping of what we need to do, right? So if it is Y, then we could have some lambda. So translate could be a dictionary of X is lambda B loses so loses lambda A loses A for Y it's this, and for this is wins A. And now we could say B equals translate B, and we call it with A. Maybe that's a cleaner way of doing this. So we have this translation table of what we want to do, and the functions, depending on for X, Y, Z, are these: loses, A, wins. And then A is this map. A is this map. We translate B. Of course, we could do this also in line, you know, like that. I don't know if we, I mean, the line is not very long. We're doing a couple of things, but it's not that bad. And this function, we could have it outside of the loop, right? So now would be we are translating B and applying it A as a function. So for AB in games, I mean, we could do this mapping of A somewhere. I would like to remove this line, right? I would like to remove this line. Let's remove it for E for I in numerate games. Let's remove it. So let's do games I 0 equals AB equals map A. With this, we're going to do all of this mapping in the beginning. So maybe we can remove this. Let's see if that works. Okay. So now what we can do is we can replace this total score with a sum. So total score equals the sum of, with the least comprehension, so round score, blah, 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 sorry, for A, B in games. So now, this is a one-liner, but it's a one-liner that makes sense to be a one-liner. And now we could even maybe rename this translate function. I think this is a dictionary, so we could call it maybe decrypt or something like that. So decrypt, which is what the statement says, right? So instead of games, so games are rounds, right? Okay, so now we have the rounds, the round score, blah, blah, blah. So now I like part 2 now. So part 2 now, it has a dictionary of what you need to do for X, Y, Z, and then it has this score, right? So we could, part 1, we could do it in a very, very similar way. Only that the decryption part will be much simpler. So the X is an R. Well, this is the decryption, right? P. Sorry, I'm messing around with this. So this is the decrypt. And now sol1. We are decrypting this. There isn't a need for this lambda. And then I think that's all. Okay, sol1. I added this underscore, which is probably not needed, but okay, so now we have the part 1 and the part 2 are very similar. There's a decryption function, and then there's a sum in which we compute the score. So now we're going also to improve this. We are going to say, we're going to unify this in a single function. And instead of game score, we're going to call it score. So score. So score equals points B. So we could say plus a score plus a score. And that is fine too. Okay, so now maybe there is even a better way. So this loses, wins. Yeah, we have this mapped here. We could maybe even, well, we will see. We can improve this also a little bit. So these scores, we compute the points, and then if it's winning, it's this, otherwise it's 3, 6 plus the points. So what is the best way? I mean, here we are summing this as C. I don't love this. I don't love this. So maybe we can simplify this somehow. Could do this, right? Points B, so we only do the sum once. So here we would do SC equals 0, SC equals 3, SC equals 6, right? So this is even simpler, I think. So if it's a tie, it's 3. If wins, it's a 6. Otherwise, it's a 0, which we have in the beginning. Here we should have the else if, just in case. And then we return the points. So I think that's good enough. So we have this score function, which we use for both parts, and then we have this part 1 decryption, part 2 decryption, solution 1, solution 2. Finally, I think we could improve this a little bit. So this is a pretty ugly part of the code, doing this mapping here. So we could, what could we do? And also we have the losses and the wins. This is a pretty common pattern. We are defining it here, and we're using it, well, we're using it later. But then here we could also define this the following way. For A, B in wins.items. So this, it may seem that it is a longer way of pointing this, but it makes sense, because what we're doing is we're reversing the wins for the losses, right? So in this way, we make sure that we don't make any typo. The points we're only using in one place, so we could even define it here, maybe, because it's good to define variables near where you use them. And the map, I think we are only using it here too. So we should probably use it only here. Then the RPS, we're using it in more places for this decryption. So the only thing I didn't like, so round is a list of, we could replace this with a list comprehension, right? So it would be, in fact, let's open the Python console 1 second, and let's try something. So if you zip ABC with 1, 2, 3, and you do a dictionary with this, you get this, right? So here, what we can do, this same thing is a dict of a zip of ABC RPS. Is that better? Is it any better? I don't know. Probably it's even wrong. So let's, oh, because I deleted the list. My point is that we could do this in a comprehension. So we could do rounds equals, so it would be map A, B, and this is a tuple or a list for A, B in rounds. We extract this map here. We can simplify this. And we could even do this in line if we wanted. So this is a way of simplifying. So this is the rock, paper, scissors game spec, we could say. So here we have the constants of the game, who wins and who loses for convenience. Then we read the input, parse the first letter in the... Even better. If we use A, B, I think this is what I was looking for unconsciously, right? If we use A, B, C as the constants, we don't need to do any mapping. So we don't need to do any of this. Of course, A, B, C is a pretty weird way of referring to rocks, paper, and scissors because it is a counterintuitive. But if we do it this way, we don't need to do any mapping. Okay, so here we could even do it in this way that we generally use. So we read the input. This is the rock, paper, scissors game spec. This is the function for the score. This is defined in the problem. And here we have part 1 and part 2. Okay, now I'm happy with the solution. It's not super short, but it is pretty clear and pretty well organized. Let's go with the lessons learned this day. I think we can find some lessons that we learned today. For example, we used lambdas for one. So we use lambda a, for example. This is the identity function with lambdas. We also use the dictionary of lambdas. This is a pretty handy way of calling in this way. So you have a dictionary in which you store a lambda, then you call this function. So that is a pretty nice trick. Then we have used list comprehensions. I already listed this yesterday, but this kind of list comprehensions, right? We could are very useful for example, for summing this element, right? If we could say simplifying, right? We could sum x in a list. So this is very useful because if you go back to the beginning, when we were summing, we had one variable which was initialized to 0, and then we were summing different elements. Now we have this sum function that applied to a list comprehension is a one-liner that lets us solve this problem of solving a list of numbers. Then, I don't know, this is just general to software engineering, but we could use define a score function common to both part 1 and 2. So that is, I mean, it can seem obvious, but it is not so much. We could solve part 1, then do a whole bunch of things, and then solve part 2, copying the code or modifying it. But here we were able to extract the score function, and the statement was very clear. The way of choosing of calculating the points is exactly the same as the one in the first part. So we can extract this as a common part. So we define the game here, the wins, the loses. I think this is a pretty good. There's not a simpler way of defining the game than this wins. This is the single source of truth, right? So these are just some constants. This is the source of truth of who wins whom in this game. This is just for convenience. We have reversed this. And then we had the common function, the decrypt dictionary with the list of lambdas. I think this is all. Today's problem was very interesting. It was pretty simple, but not super simple. But I think it was especially interesting how we can go from a long solution that works, but is not the most intuitive one, to a solution that is much better. It is more understandable and it is more simple. Okay, have a nice day and see you tomorrow.